Alright, so good day. This will be the last module for the midterms, and it will be serving as your very short discussion regarding universal law of gravitation. So upon the formulation of the Newton's law of motion, Newton also realized that there should be a force or something that holds the heavenly bodies together, and thus, after inventing all sorts of stuff like calculus, no, together with Kepler's law of planetary motion, he developed the universal law of gravitation. So it goes like this. Okay, so this is basically the only equation that you have to remember. So that's that easy. All right, so you have this equation. So these values here are all multiplication. All right, so on the left hand side you have force, or specifically gravitational force. All right, then we have here on the numerator you have the gravitational constant and the masses of two objects. So we're going to have a very idealistic system only dealing with two objects. All right, so and then the distance that separates them, we're going to call it r. Okay, because it can be located at any axis, so I cannot name it at x, y, or z, right? But instead we're going to utilize r as the absolute distance between these two massive objects. Right, so going back, gravitational constant has this unit. Okay, so I'm going to show you later the importance of the units in cancellation. All right, so let's have some guided practice problem to further understand the topic. Then after this, you can now proceed on taking the last written works, which will basically bolster your scores. All right, so here, so for your first problem, we have a 50 kilogram person and a 70 kilogram person sitting on a bench close to each other at a distance of 0.5 meters. So we're going to calculate the magnitude of their gravitational force, okay, or the force that causes the attraction between them. Okay, so let's open the paint here. So for our given, wait, first let's illustrate. So I'm just going to show. Okay, so this is our first person that has a mass 1. Then this is the distance between them, which is of course r. Okay, then we have here our second person, which is mass 2. So just imagine that they are sitting. Alright, so we're going to look for the gravitational force, or F sub g, okay, which is drawing them to each other. Alright, so for our given, we have mass 1 as, what's that, 50. Okay, 50 kilograms. And then we have another one, which is what, 70 kilograms. Okay, 70, right? 70. Okay, then we have the distance between them at 0.5 meters, right there. Then for our required, of course, we have F sub g. For our equation, of course, the just substitute, diba? F sub g, g m1 m2 over r squared. Okay, so you just have to memorize big G. So if you cannot, just write it on your given as well. So big G is 6.67 times 10 raised to negative 11. Unit is, what's the unit? Let's return meter cube over kilogram second squared. Meter cube over kilogram second squared. There you go. So upon knowing those, you can now just substitute, because that's easy. Okay, that's how easy this topic is. Alright, so you have 6.67 times 10 raised to negative 11, correct? So you have meter cube per kilogram second squared. Okay, then you have 50 kilograms. Okay, so they're all in the same unit, so you don't have to worry. Then you have 70 kilograms. Okay, all over what's our distance? So that's 0.5 meters to be squared. Okay, so I'm just going to do this now. So cancel this because this will be squared, right? So cancel that. So you're going to cancel this. There will be 1 remaining. Okay, next. What can you cancel? You can cancel. This will be kilogram squared. Divide by kilogram. So what would that be? So cancel this and this. So you're going to have kilogram times meter divided by second squared, which is basically newtons. Okay, so you see we have made Newton emerge from the equation. So for our answer, of course, f sub g is something something. So let's open Desmos to show the solution. So we have let's move this so we could see it. So we have let's write the fraction. So that's 6.67 times 10 raised to negative 11. Okay, and let's put that inside the parenthesis. Then we have 50. Okay, then we have 70 all over 0.5 to be squared, of course. There. So what's our answer? 9.34. Okay, just retain the up to the hundredths place or 2 decimal places. Okay, so that's 9.34, correct? Times 10 raised to negative 7. Our unit is, of course, in newtons. So let's check. Okay, so there. So no missed what do you call this? Solution, right? So I hope you got that correctly. It's really easy, correct? Right? So we can now proceed on another problem. So let's have that. Okay, so here's guided practice problem number 2. So what is the force of gravity acting on a 2000 kilogram spacecraft when it orbits 2 Earth radii from the Earth center? So just some fancy words. Regardless, it's still easy. Alright, so the mass of the Earth is there. Okay, so let's proceed on solving that. Okay, so we have, so let's say this is our Earth. Okay, so this is 1 radii, then this is another radii. Okay, so making it 2 radii, correct? So let's say our spacecraft is somewhere here. Okay, so there. So this, let's say this is our mass 1. Okay, then our Earth is mass 2. Alright, so we can now write your given. So we have mass 1, which is 2000 kilograms, and mass 2, which is, what's the mass of the Earth? So heavy, right? So massive, I mean 5.98 times 10 raised to 24. Our unit is in kilograms. Then next we have 2 radius. Okay, so our distance will be 2 times 6,400 kilometers, right? Which is, of course, 12,800, correct? There. So our required is, of course, f sub g. There's no something new about it. Equation, of course, just write that one. So you would have a complete, how many points? 5 points. Okay, so there. Then proceed on your solution. So you have, so I hope by this point you already just memorize g, so you don't have to place it on your given. So that's 6.67 times 10 raised to negative 11. Our unit is meter cube kilogram second squared, correct? Multiplied by 2000. Okay, and then what's this? 5.98 times 10 raised to 24 kilograms. Okay, all over. Make sure that you extend the division bar. Okay, so our radius is, or our distance I mean, is 12,800 kilometers. Okay, so before we do that, let's convert this first. So this will become what? Just write it here, 800, then add another 3 zeros, so that's our kilo, right, in meters. So wait, let's just back up a bit there. So convert this first. So this is 12,800, plus add another 3 zeros because this is in kilos, no? Then that's it. Then just write it in scientific notation because it's too long. So that's 1.28 times 10 raised to 367, correct? Then our unit is of course in meters. There. So square this. Okay, wait, square this. So you're going to cancel, of course, meters here, but of course you're still going to square this one. Then cancel meters here, so you're going to have remaining 1 kilogram, just cancel 1, this one, so you're going to have meter, kilogram, then second squared. There, so that's it. You can now plug in your answer. F sub g is, let's open Desmos. Wait, let's adjust it more. There. So what's this? Let's copy this because it's easier to edit. So this is already okay. So this one would be 2000, then this would be 5.98 times 10 raised to how much? 24. Alright, then this will be 1.28 times 10 raised to 7. There. So what's our force? So the gravitational force felt by your satellite is 4,868.97. Correct? 4,868.97. 4,868.97. Of course, our unit is in meters. Let's check that again. 4,868.97. There. So you can just box that one. And that's it. You see? It's not that hard, right? So you can now proceed on taking what? Written work number 4. So it will be like a bonus as long as you understand how to operate this variable. By the way, before I send you off, you can derive this. Okay, I'm just going to write it here. So let's say you're given with an equation like this. Okay, m1 m2 over r squared. You can, let's say on the question you are asked to look for r. Okay, so you can have, of course, multiply both sides by r squared. Okay, so cancel on this side. So you're going to have fg r squared is equal to g m1 m2. Then divide both sides, of course, by f sub g. Cancel. Then you're going to have r squared. Yeah. So that's g m1 m2 over f sub g. Then of course square root both sides. So you're going to have, so you're going to have this. Okay, so which is r is equal to g m1 m2 over f sub g. So you're going to have, for example, this kind of equation in solving. Alright, another one would be looking for the masses. Okay, so let's say you are tasked to look for mass, but you are given what? The sum of their masses. So let's say instead of having individual masses, what is given on the problem is the sum of the masses. So let's say the sum is n. Okay, so the sum of these are the sum of the masses. So let's say this is what is provided on the problem. So to set an equation, so to utilize of course, universal law of gravitation. So you're going to set m1 as, of course, m1. Then for m2, utilizing this equation, so this is your equation 1, this is your equation 2. Then substitute, rearrange this one, okay? So this is m2 in terms of n and m1. So this will become, transpose this to the other side, so this will become n minus m1. Okay, so what would be the consequence of that? Knowing that this is your equation, this is g m1 m2 over r squared. Okay, you can substitute m1 and m2 to this, so that will become f sub g is equal to g m1 times n minus m1 divided by r squared. So let's say you're going to look first for m1. Okay, so I'll just solve it here on this space. Okay, so let's distribute that. So f sub g is equal to g m1 times n is m1n, of course, minus what's this, m1 squared, correct? Is that right? Wait, let's operate on, let's have this remain first on that side. So let's do that. So gm1 times n minus m1 divided by r squared. So multiply both sides by r squared, so you're going to have fgr squared. Then divide both sides by g, you're going to have g here. Then you're left with m times n minus m1 there. Then distribute this, so this will become fgr squared over g is equal to m sub 1, this is m sub 1, okay, minus m sub 1 to the square. Then you can rearrange that. It will look like this: m sub 1 squared minus m sub 1n plus f sub g r squared over g is equal to 0. So you're basically going to have quadratic equation. So you can utilize the quadratic formula to solve for m sub 1. So that's it. You can proceed on taking the bonus written work. So that will be about Newton's law of motion and universal gravitation. That's it. Thank you so much, guys, and good luck. May the force be ever in your favor.